Alright guys, welcome back to my channel. In this video I am going to talk about the web feature services, and one thing actually I want to remind you that I created the GeoServer and Leaflet web-GIS playlist. In here I go through the basic installation and why GeoServer crash course, and GeoServer with Leaflet, and everything you need to know about GeoServer using a Leaflet. So in this current recording also I'll put it in the this playlist. That means if you follow this playlist you will get the all the required information about GeoServer and Leaflet web-GIS. So I'll put this playlist link in the description below, so check that out. And in this video I'm going to talk about the web feature services, its features and its importance, and I'll compare web feature services with the web map services, which I explained here. Web map services, it's the crash course about WMS, you can check that out. And then I'll explain about its current request types, and then I'll go through each with the Leaflet. So if you want to know everything about web feature services, you can check out this document, which is the document provided by OGC. So here they explain about the WFS in detail, so you can download the WFS document and then you can read if you need everything about the web feature services. Also here is the another reference from GeoServer, so it's quite good for understanding everything you need to know about the web feature services. So I'll also follow these references, and I'll try to go through each of the requests, and then I'll try to explain in detail. So let's get started. So first thing, I want to go through this presentation slides, and then I'll explain about each feature request in the video later. So let's get started. So web feature services, let's introduce it. So web feature services is the actually it's the standard created by OGC for creating modification and exchanging the vector data. That means web feature means only the vector data. We cannot exchange the raster data, so it's all about the vector data. So we can get the data through server, and then we can edit, modify, or even we can visualize it in the web-GIS applications. And WFS encodes and transfer information is in GML, graphic markup language, or subset of XML. It's the kind of XML kind of language, so we can get the information. What WFS will do is it will encode the our request into the GML, and then it provide the XML like document, and then it will give us back to the data in required format, so that we can visualize it in the web-GIS applications. And WFS also support the development and deployment of collaborative mapping application. So that means if we build the web-GIS using WFS, then we can visualize the data, and we can make a tool to edit the data, and then also it support the multi-user collaborative mapping application, so that every user can see the layer, and then every user can edit the data. And currently GeoServer supports three version of the WFS, 2.0.0, 1.0.0 and 1.1.1. so that means there is slightly different between these versions. So there might be in the case of 2.0.0 there are some extra requests we can make. I'll show you later. So here is the comparison between WMS, web map service, and web feature services. So web map service is the image of geographic data. So I already explained in my previous video tutorial. So WMS is only the image, so it can be fetched from the server easily, but the WFS is the actual feature with geometry and attribute. This geometry can be visualized in the web-GIS application, and this attribute can be also get when we click the map, or we can get this attribute and make it dynamically editing or changing things. So, and the difference is can load faster, don't matter the size or format of the input data set. Since it's just the image, so it will load faster, obviously we know that, and then the format of the input data set, it does not matter whether the data is raster or vector. But in case of WFS, it will load slower if our data set size is increasing. That means if we request server to get the more data, then it will take more time, because it's the actual feature with geometry and attribute data. So basically you can compare treat WMS as a image georeference image, but WFS is a GeoJSON data in case of Leaflet, because we are going to visualize our WFS data in the GeoJSON format. So WMS, since it's image, so we cannot edit by the client, we cannot create the style in the client side easily, but it can be edited. WFS can be edited, since it makes us available this WFS-T request, that means web feature service transform. So we can change our data set through client, and then we can send it back to the server. And the difference is can be used for any kind of raster or vector data set, this WMS, because it's the image. But in case of WFS, it's the feature. That means we cannot get the feature from raster dataset. It's only available for vector dataset only. And the difference is we cannot download the actual dataset. The only available formats are image. Okay. In WMS we get only the image, but in case of WFS we can get the actual dataset. So these are the most common difference between WMS and WFS term. And let's go to the operations, or we can say it is the request types. So here in the WFS also we have this GetCapabilities request is available. That means it will provide the detailed metadata about the WFS server. So I'll get through each in the video later in the course, later in this tutorial. So this DescribeFeatureType, it will return the feature type supported by WFS service. So this will just return the description of feature type supported by WFS service. And GetFeature, actually this request is the most important and the most useful request from WFS. So we are going to go through very different kind of GetFeature request later in this video tutorial. So what it will provide is, it will provide the feature with geometry and attribute data. And this transaction request, this means as I already explained, it's the WFS-T request. That means we can edit the existing feature by creating, updating or deleting. And the request is lock feature. What it will do is, it will prevent the feature from being edited through a persistency feature lock. That means when one user is editing the WFS, one particular WFS request, then we don't provide the other user to edit the same data. That means it will lock the feature, and then it can be serialized when other user try to visualize it. So that means we provide the this lock feature. What this request do is it will lock the feature from editing. And here are the most commonly used WFS output format. GML2, which is the default output format for WFS 1.0.0, and then GML3 is default option for 1.1.0 and 2.0.0. And these two output format we did not use that much because it's the XML kind of language, so we don't need this data for web-GIS application. Obviously we are going to look through these three formats: shapefile, JSON and JSONP. This JSON and JSONP format will provide the GeoJSON data, so we can visualize it in the web-GIS. This shapefile format we can make the download data link, so that user can download our data in the form of shapefile format. So yeah, so these are the main things from WFS. Okay, let's go through it. We can connect this WFS with the leaflet, and let's try to figure out what here going. So here I have created the wfs.html file, so I'll provide you this file in the description below. So here I wrote the simple leaflet kind of things. So I just put a title, and then I put leaflet CSS and leaflet JS link. I also loaded the jQuery, and then I provide some styling like map height and width, and then I have this inside body tag I have ID map, and then I initialize the map in the certain coordinates, and then I loaded the OSM map. So if you run this with the live server, or you click on the same index, this web wfs.html file, you will just get the map zoom to the particular location. So okay, let's go one by one. First thing is we are going to show the GetCapabilities request. So for that, make sure you have the GeoServer running. So if your GeoServer is not running, then you can simply run it by the local disk, and then you can go to the GeoServer installation directory. So in my case it's inside program file 86, and then it's inside bin, and then I have to startup.bat since I am in the window machine. So I think my GeoServer is already running. I'll close this, and then I'll run it as an administrator, so that our GeoServer will be running here. So after that, after running this GeoServer, you can actually load your GeoServer by typing localhost 8080 GeoServer. So I'll just log in here. So after login, you can simply go to the layer preview tab, and then here are all the formats that available in the WMS and then WFS. So in the case of WFS, we have this kind of this all kind of output. So we can output KML, CSV as well. Also we can shapefile and GeoJSON. These are the most common output formats. So let's try to get the GetCapabilities request. So for that, maybe I'll close these things. So I'll go through this reference. So it's also pretty same thing what I am explain in the my presentation. So here is the example of GetCapabilities request. So let's try to load it here, and then just change this example by localhost 8080/GeoServer. Okay, so what it will give us is, it will give us all the information from WFS. So that means we can get this title, abstract, and also we can get these these are the GetCapabilities, and these are the output formats: text XML, and then text XML, GML2, KML, shapefile zip, and then other things also. So also we get the layer name, and then the layer, I think layer bounding box. This lower corner, upper corner means the bounding box, and coordinate system. We get the each layers. So yeah, these are the most useful things that we get from the GetCapabilities request. So make sure if you have lots of data, then your GetCapabilities request will take time, because since I have only, I think, around 10 data set, only 12 data sets, so it's loading faster. But if you have the lots of data set, then this will take time. So here in the GetCapabilities request, you have to provide the service, version, and request tag. So here in the service we have obviously WFS, and version is you can modify it 1.1.0 or 1.0.0 or 2.0.0. Pretty much everything, all the things are same with the version, I think, in the GetCapabilities. So yeah, so and other things like you can provide other parameters as well, like server identification, server provider, operation metadata, feature type list, and feature capabilities as well. So I think these are the some optional things, so I think I don't want to go through detail of each. So here in the describe feature type request, so we have to provide server, version, and request type. Obviously our request is the describe feature type, and then also we have to provide the type names. This means the name of the layer, then these two things we don't need to provide. So let's so I'll just I just want to copy these things and then paste it here in the documentation. So get capabilities request, it's this request. So and the describe feature, QUEST. These things is just for the reference, so I just paste it here. Maybe where is GeoServer reference? Okay, I'll just copy these things and show you what it will give us the output. So in example.html I have to provide localhost 8080 GeoServer. I think I forgot to provide the one parameter called type names, because it's the required things. So I'll provide the type name as well. So and type name equal to, and then our name of the one layer. Make sure you provide the name of the your vector data set. So okay, there is something wrong, so let's try to figure out. WFS service, version, request, describe feature type, and type name. Okay, everything looks type names, maybe type names, but it is still throwing the error. But what it will give us is, it will give us the one layer information. I think there is some issue, so let's try one more time without type layers name. So I think here localhost 8080 is missing. So here we got the this information about the all the layers. So describe feature types request will provide us the this XSD document, which is the kind of XML document which provide us the information about all the layers. So that means first layer is BU 2020 A0S0, and then my second layer is LP 2020 A0S0. so it will provide us the like column names. I have these column names, these are from the this shape file. So for this table, this feature, we have this kind of column names, and here is the states shape file. So it has this type of column. So it will provide us the everything about the WFS or WFS data set. So I think let's try to provide the type names as well. So for me, the type name is topo BU 2020 A0S0. so I'll provide this, and I just noticed that here localhost is missing, localhost 8080/GeoServer. So here it will provide us the information about only the our requested type. So in this XML, you can see that we provide BU 2020 A0S0. that's why it's providing us the information about only the particular specific layer. So we can get this information, column names, and we can make the query based on these column names now. So yeah, so this is the get feature request information. Also you can provide the output formats, like what you want to find out here in the request output. So you can provide that as well. So you can try this. So for the information, I'll just put these things in here. This localhost is missing somehow, I don't know why. I just provide these things for your reference. Okay, so save it, and then okay, let's go to the another request. So get feature request. So get feature request is the kind of main request from WFS. So I'll go through everything that you need to know about the get feature request. So first thing is, for simply getting the feature request of one specific layer, so you can provide this kind of information: server, version, and request in type names. Type names means your layer name from the GeoServer. So just I'll copy these things and then paste it here, and then I'll change this example.com with localhost 8080. Unknown namespace, since our namespace is unknown, so I'll just copy these things and then paste it here. So okay, by default it will provide us the as I explained here. So it will provide us the if it's the request 1.0.0, it will provide us the GML2 format, and it's if the request is 1.1.1 and 2.0.0, it will provide the GML3. So that means I think this version is 1.1, then it will provide us the information about our GML3 object. So here you can see the GML text. So I think it's not useful, not much useful in the web-GIS application, because in web-GIS application with basically if I have to talk about the leaflet, then the GeoJSON data is the most commonly used format. So these things is not very useful, so that I have to provide the output format as well. So maybe from okay, let me go to the another page as well. So here I can provide the output format as shown here. So I'll just provide this output format text here. You have to provide and then output format, and then equal to, and then what you want to output. So for my case, I'll just try the JSON data. that means it will provide the GeoJSON data. So these things, GeoJSON data directly coming from the WFS request, so you can just copy this link and get it through the some kind of AJAX request, and then you can visualize it in the web-GIS application. Okay, so for that I think let's talk little bit about the WFS, and then I'll show you how to do get this data from in the leaflet, and then how to visualize it. So here in the WFS you can see that in the get feature request we have different kind of, like, we can filter the data by feature ID as well. So that means it will get the all the features from our GeoServer. So if you visualize it, here is the I think let's visualize it with the just open layer. So here these are the each feature, so we can filter these features by the FID. So for filtering this with FID, we have to just provide the FID feature ID name equal to our feature ID, and also we can count based on the YAN numbers. So here based on the count we can provide the number of features that we need to load. So this count method, or this count parameter is available for 2.0.0, and it's named as the max features for the earlier WFS version, that means 1.1.0 or 1.0.0. So here this max feature or count, whatever you say, this things is very important for filtering the data. So let's suppose you have the huge amount of data coming from WFS, then the browser cannot hold this data at the same time. So you have to filter this data based on like number 100 features per request, or you can say that the 200 features per request. So you can by default it will provide the all the features. So if you provide the what is my 2.0.0, that means I have to provide the counts. So if I provide this count parameter here, so and count equal to like okay, 2 features, I'll get only the 2 features, random 2 features from our WFS request. So you can filter up to like 100 features, then you can filter only get the 100 features from server. So this is the important feature, so to hold the all the data sets. And then also we can provide the sort by feature. So we can sort by the attribute, that means our attribute names like BU or use based on these columns. So we can sort also. Let me try sort by, maybe by equal to our BU column. So it will sort our data based on the BU names. So here it's the integer field, so it will get the 1 at the first and 2 at the second, and then it will go up to 100, I think. And also you can sort by the attribute D plus D, that means it's the descending order. So by default it will be sort our data in the ascending order. If it's the number, it will go through 0 1 2 3, and then if it's the string, it will go through ABCD, something like this. And then also here is the we can restrict our get feature request by the attribute rather than feature. So let's suppose you want to get the only data about the let's suppose you want to get this particular data only, then you have to provide the BU equal to 190 as the parameter. So here okay, what we have to do is we have to provide the bu equal to, and then we are going to get this only 190 feature. So let's try it. So these are the all the features that has bu value only 190. So you can get that in this way. And also you can filter like property name, you can like 190 and then comma and the value like this way. So yeah, so these are the most common way. So if you want to filter based on your bounding box, that means if you want to filter to the particular region, so you can provide the bbbox parameter as well. So also you have to provide the SRS name. By default it will take the default SRS, that means the coordinate system. So these are the main things from WFS. So let's try it in the leaflet. So here maybe I'll put these things at the bottom of the file. Not in the bottom, I think. Okay, is the HTML comments. So let's get our WFS feature from our leaflet application. Alright, so getting the GeoJSON data. So I already loaded this jQuery, that means we can apply the jQuery function. Here is the getJSON function, and then you have to provide the URL. So I'll write the WFS URL, and then I'll just simply copy and paste this URL from here. So select all, copy, and then maybe I'll paste it here. For now, in this case, I think I don't want to filter this data, so I'll just leave it as it is. So just the default parameters, and inside the getJSON function you have to provide this URL, and it will return the promise. So then you can provide the then and then response, and then you can write this is the ES6 arrow function. So you can write the arrow function in this way. So res, and then you can type console log res. Okay, let's try to get the response from our this URL. So if you check here in our application, it will provide the exact same kind of WFS data set from the server. So you can get the exact same URL from here as well. So if you type the WFS and then GeoJSON, so you will get the same URL which I am currently using. So this %3a means just the colon, it will work the same. %2f, it's the slash, so it's the same thing. So okay, so in that way we can get our GeoJSON feature in the leaflet. So we just need to load these features in the leaflet. So for that we have the function in leaflet called yal.geojson, and then we have to provide this response. Our response is the GeoJSON data, and then add to map. So let's try to save it, and if I reload this, so something is wrong. Let me see the error. So maybe due to some error, let me try the var layer equal to, and then I can fit this layer using map.fitBound, and then layer.getBound, so that I can zoom to the layers. So if I save it and then open my here, layer.getBound is not a function. Get BOU, I spell it wrong. Okay, so okay, my layer is available in this boundary. That means I think it's the coordinate system issue. So if you check the WFS reference, you can provide this SRS name parameter as well. So I'll provide this SRS name parameter and then set my coordinate to maybe end SRS parameter equal to EPSG, and then in my case 4326, that means WGS 84 coordinate system. So SRS, not SRS parameter, SRS name, sorry. So if I check my web-GIS, now it's the exact same thing which is coming from our GeoServer. So here in the layer preview tab we have these layers, so we visualize find this layer in the leaflet and then visualize it. So one thing you notice, there is only limited feature are available, so maybe this is due to this count property. So I'll just remove this and then it will get us the all the features. So it's the GeoJSON data, so you can make it the pop-up feature available, and then you can apply the styles as well. So I think for that you have to provide just the function and then feature layer, and then you have to write the function here. So sorry, we have to pass the object, not the function, and then we can pass here on each feature property. So on each feature, and then we can pass the function fl feature and layer, and then we can layer dot bind pop-up. It's not the part of our WFS request. If you are not confident with visualizing GeoJSON data, then you probably check out my leaflet tutorial. So bind pop-up, and then you can provide the bind pop-up parameter. So for my case, I think it's inside the feature dot properties dot for this example I'll provide pop up the BU field, and also you can provide the style as well. So for the style, I think I'll create the one variable here, GeoJSON style, and then I'll create the style something like, I think I'll just copy and paste things from somewhere, just fill color and color, and then weight opacity and fill opacity, these things, and then I have to provide the style. So GeoJSON style, I think it's not the standard form style, and then style. Okay, so if you look your layer, so you will get the this kind of style. That means we just set our color, fill color to the this hash code. That means it's kind of this color, and then we provide the opacity and fill opacity as well. You can change these parameters. So if you click on particular layer, so it has to provide something. So let me try to provide like BU and then plus and then f.properties.bu. So if you click in layer, so it's still not working. So that means there is the problem in on each feature function. Okay, so on each feature, I think this maybe this O is capital, that's why on each feature, and then we can just if we click we will get the BU code. So that means it's the 52 and it's 15. So let's try to get and the field as well. So maybe use a field. So here what you can do is you can provide the like BU and then you can provide like this, and then also you can plus and then use, and then you can write the f dot properties dot use. Okay, so if you now click on the any point, so you will get the view and use these things. So maybe here. Okay, so in that way you can just visualize your WFS dataset in the leaflet. So these things are not the part of WFS tutorial. This is the just GeoJSON visualization kind of things. So you can if you don't know how to visualize, you can check out my leaflet from basic to advanced course. I just remember one thing. If you did not enable your cards enable your cards, so you won't get the WFS directly from this getJSON function. So for the enabling cards, so I already mentioned in the my previous videos tutorial. So for the enabling cards, you have to change here in the GeoServer, web-ini and web.xml file. So make sure you already enabled this JSONP, and then you already enable your cards. So you already oncoming these features if you are in GeoServer, or these things if you are in Tomcat server. Here also don't forget to uncomment these things. So I already explained in the I think WMS video lecture. So you can probably watch this how to enable cards in GeoServer. So you just need to uncomment these two things from these three things from here, and then you just need to save it. So in that way you can get the WFS request. Also one thing I just want to remind you, so maybe if you are interested to get the WFS request from GeoServer using Leaflet.js, so I also wrote the tutorial in the Medium. So here I explain how to do these things. So if you let's suppose if you want the JSONP dataset, then you can follow this kind of syntax. So you just need to provide the data type as the JSONP, and then this informations, and then you can get the data, and then you can add this to the map. So this is little bit complicated. I set up everything, and also you can provide SQL filter here, so that you can filter your data set using this AJAX request. So okay, so I'll provide this tutorial link in the description below. If you need in the JSONP format, definitely you should check this out. Okay, so let's go back to the other things. So here we already look about the WFS get feature request. So let's explain about log features request. So this is the feature that that can ensure that if the one user is editing data, then we lock this feature, and then we don't enable this layer to update by other users, so that the data can be serialized. So this request is not very much useful. So here is no any example, also no any example is given, so I'll just leave it as it is. And here in the transaction request, so that means WFS-T, sometimes we call it as WFS-T. And then here this transaction means we can edit our layer using the WFS request. So for that I think I have to open the some applications, like for my case I'll open the QGIS, and then I'll show you what this WFS-T request means. So I have to add the layer from the WFS layer. So I'll create the new, and then I'll name it as the WFS GeoServer. And then for my URL, I think I have to provide the URL of WMS up to this, I think. Okay, so just click OK, and then you can connect this. After connecting, you will get all the WFS requests from our GeoServer. That means these are the vector data which support WFS request. So in my case, I'll just try in this data set, so I'll just add this data. So after adding this data here, actually this data is loading from our GeoServer directly. So rather than loading the shapefile, so you can load your WFS data from URL like this. And then also you can make changes to these layers. So for making changes to this layer, you have to make sure after before doing WFS-T request, you have to make sure in your workspace you tick all the services. That means you checked all the services here, so that it support the, basically main thing is WFS, so it support the WFS request from other user as well. And other thing is, like, you have to select the services, sorry, not in the services, I think data. So you have to provide this right rule. So that means you can click on the right rule, and then you have to provide this role anonymous. By default it will be listed here, so available role. So you have to select this role, and then you have to provide it in the selected rule. So it's the right access. That means the anonymous user may have to update this feature. So after that you can click save, and then maybe you may need to restart your GeoServer, so you can make the transaction. So let's suppose if you want to change the attribute names. So maybe the let's suppose this people field. So if you want to change this people field 1 to like 6 for this BUID 0.39 and W01, so you can just put 6, and then you can just save it. So just save it. So after saving, you will updated it successfully. So your GeoServer also get the if you try to load this data, so it is successfully updated. So you can update your data like this, as well as you can update your geometry as well by using the editor tool. Since it's the WFS tutorial, it's behind the scope, so you can try to editing these things from QGIS as well. You can develop the same feature in web-GIS applications as well, so that the user can change the features, and then the user can change the attributes and then provide. So I think that's all about the transaction request. So also there are a couple of things which can be do in the WFS version 1.1.1 only, get GML object. Since we are not dealing too much with the GML object, it's kind of XML kind of language, so it's not properly used. So other thing is like get property value request, which is only available in version 2.0.0. what it will give us is, it will give us the, I think, attribute table only. So you can try these things. Also here is the get feature with lock request. So what it will do is it's the similar to the get feature operation, except that when the set of feature are returned from the WFS server, feature are also locked in the anticipation of subsequent transaction operation. So it will lock the feature when it return the WFS, when the feature return from WFS server. So another request is create stored query request. So it's kind of complicated, and then I think it's not widely used. So you can try and search more detail about this kind of request if you need. and the thing is drop stored query request. So it's also only available for the 2.0.0 only. So you can here is the demo of this request. You can try this. So and the request is list stored query request. So here is the demo. What it will do is it will return the list of the stored query currently maintained by the WFS server. So it will provide us the list of stored query. And the thing is like describe stored query request. It's similar kind of request, similar to list stored query. So but you can provide other additional features as well. So here it wrote describe stored query operation, return detailed metadata about each stored query maintained by the WFS server. So it will return the metadata about the stored query, this list of the stored query. So these are the main things. So in the output format, here are different output format available. So in case of say files, so the size is limited to 2 GB, so you cannot get the more than 2 GB file. And then also if you are storing it as the shape file, then make sure your column name will be terminated to the 10 character, because it's the property of shape file. So these are the common things which we have to make sure while returning our data to the shape file output format. And then other thing are like JSON and JSONP format. So these two are commonly the same kind of output formats. So you can see the more detail about this request here. So I think that's all. So before concluding this video, I just want to make one download data button here, so that user can download the data. So for that, I think I'll create the button, and then button is linked to the I think the actual data set. So I'll provide this link here, and then I'll change the output format to the zip shapefile. So let's try the shapefile zip format. Where it is here, and then I'll provide here the download zip CSV, and then I'll just save it. And then if I check my my web-GIS application, so you will get the download zip shapefile button. So if you click this link, it will download the shapefile from our server WFS request. So it contain all the required files, and if you load these shapefiles, it is the exact same layer which we visualize here. So in that way you can make the download data button as well. You can edit the data. So the WFS is really important for editing and managing the data in this way. I think that's all about the WFS things. So I hope you enjoyed this video. I'll see you in the next.